Welcome to lecture 3 in the shed.
Hi. Okay. Today I'm going to be talking about series. Okay. And a series can be thought of as sum of the terms A1, A2, A3, all the way up to AK, where K is a dummy index that represents the numbers 1, 2, 3, all the way up to N. Now these sums can be thought of, as a series. Now, we can sum infinite series, like that. We use this summation symbol, So we got infinity on the top, which means it goes up to infinity, So K equals 1, AK. Now this, what this here means, A1 plus A2 plus A3, And it just keeps going, it doesn't stop because it goes up to infinity, So what happens is, you get that. What that actually means is, it's a limit, as n tends to infinity between 1 and n of AK. Well, K is a dummy index, It's just a limit. It's n tends to infinity, Because it just keeps going, Because it's got infinity on the top, so it just keeps going, It's the limit, it's n tends to infinity there. That's all it is, Now, to use this segment notation, which I just used, what we need is a general expression for the term AK, So I'll give you an example, right? Say, for example, and I'm going to write e.g., that's short for example, right? So if we're given this series, right? But it just keeps going all the way up to the last bit, which is minus 16, We can write this as this, I think. 16 on the top, because this is the last one I'll show you now. 1 over n. As minus 1. See, minus 1. Is that right? We can see that we got this term here because the sign alternates, So even powers are 1, odd powers are minus 1, and minus 1, right? So that's why the sign alternates. Now, it is possible you can have a case where the infinite series, right, is not computable. What I mean by this is the limit is n tends to infinity. It doesn't exist, The limit as n tends to infinity doesn't exist. Now, in this case, we say that the series diverges, If it doesn't diverge, it converges, So if a limit as n tends to infinity doesn't exist, it diverges. Alright? Now this brings us neatly on to geometric series. Now this is a series that comes in the following form: A plus AR plus AR squared plus AR to n minus 1. This form where A is the first term and R is the common ratio, right? So what do you times that by to get that right? Right, common ratio between terms. Okay. From this little miniature proof here, you can see that the sum of the series given by A, the first term, 1 minus R to the n, that's a common ratio, and 1 minus R. Any questions?
I have a question. Sorry, let me just...
Now, given that the modulus of R is not equal to 1, we can see whether a series converges like this. If mod R is less than 1, then R to the n tends to 0 as n tends to infinity, and the series converges. Mod r greater than 1, and r to the n tends to infinity, and then tends to infinity, and the series diverges. If r is equal to 1, limit as n tends to infinity as n is equal to plus or minus infinity, and so the series diverges. Monkey, monkey! For example, prove that. Whoa! Alternatively, we can write this like this. Okay. Well, consider this. N, and we'll call this one number 1. We'll call this one number 2. Now, if you'll just bear with me with the board space, if we add 1 and 2, we get this. Right, we get this, 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 which gives us n plus 1 plus 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 n plus 1. Hence, n plus 1 2. If you think there's more we can do, come to the office and see me. A few properties of convergence series. Now it's either the sum of AK plus BK is in fact equal to sum of AK plus sum of BK. Now if we sum of AK minus BK is in fact the same as the sum of AK minus the sum of BK. But the sum of AK times BK is not the same as the sum of AK times the sum of BK. Here's just a couple of series limits that you might need to know. You might not, but you probably will. Over 70 society. So it'll converge if P is greater than 1. It will diverge if P is less than 1. What happens if P is equal to 1? If P is equal to 1, my friend, then we have this, which is known as the harmonic series. And this diverges. It diverges. Yeah! We say, alright, that this converges absolutely, if, yeah, the sum to infinity of mod AN converges. So we say that this converges absolutely, if that converges. And if this half of 30 they add converges absolutely, then this, guess what? It converges. Whoa! Whoa! Now, if you think that there's more that I can do, come to the office and see me. Thank you very much for listening, and I look forward to seeing you again.